So in part 4, we have a couple more examples to work. We're actually going to work example 3, part D, because it's on the next page. It's easier to take a break there. This time, they're telling us the endpoints of the diameter are at 1, 4 and -3, 2. So if you remember your geometry, the diameter is all the way across. So they're basically telling me a point on each side of the center. So 1, 1, 2, 3, 4, and I have -3, 2. So the circle, whoops, is doing this, going through my points. Well, they didn't give me either piece of information we need. We need the center and we need the radius, but they gave me everything we need in order to be able to find them. So let's go find the center first. We're going to recognize that the center is the midpoint between those 2 points. So it is the point that's halfway between the two. And we have a formula for that. So that was x1 plus x2 divided by 2. And y1 plus y2 divided by 2. So we would have 1 plus a -3 over 2. And we're going to have 4 plus 2 over 2. So 1 plus a -3 is a -2 over 2. 4 plus 2 is 6 over 2. So we're going to get -1, 3. So we now know the center. And I'm going to write it up here because I obviously need more room. So the center is at -1, 3. So we found that. So, and that kind of makes sense in terms of my picture. There's my center. But we still need the radius. So you have a couple options here. I'm going to go with what I think is the more logical option. I just erased my point. I didn't want to do that. This radius is the distance from the center to an edge of the circle. So we can find this distance here and call it the radius. You could go all the way across, but that would give me the diameter and I'd have to remember to cut it in half. So a lot of times you don't remember to do that. So we're going to go the other route. So we're going to recognize that the radius is the distance from the center, which is at -1, 3, to one endpoint. It doesn't matter which one you use. I'm just going to use them with positive numbers with it. So our radius, which is really that distance, is going to be the square root of 1 minus a minus 1. That's 1 plus 1 quantity squared. And 4 minus 3 quantity squared. Well, 1 plus 1 is 2, which we're going to square. 4 minus 3 is 1, which we're going to square. It's going to give the square root of 4 plus 1, or the square root of 5. And there's our radius. So not too bad. Now we can write the equation of our circle. We've got x minus that minus 1 from the center, quantity squared, plus y minus 3, quantity squared, is going to be equal to the square root of 5 squared. So when I square that radical, I'll just get the 5. And there's the equation of the circle. I like this problem. I think it combines lots of things together, right? So it's a good problem. In example 4, we look at an application of a circle. So example 4 reads, the epicenter, the point of origin of a large earthquake, was located on a map at map coordinates 3, 7. Sorry. So our center is at 3, 7. Okay, with the quake being felt up to 12 miles away. Wait a minute, that would be the radius. So a radius is 12 miles away. They want us to write the equation of the circle that models the range of the earthquake's effect. So this should make sense, right? So we're at some point 3, 7, and we're saying that 12 miles away, you could feel that quake. So to write the equation, all we have to do is x minus 3 quantity squared plus y minus 7 quantity squared. And that's going to be equal to 12 squared, which is 140. So there's the equation. That was pretty quick and simple. Part B specifically says use the distance formula to determine if a person living at the point 13, 1. So way up here at 13, 1, way out here at 13, 1, will we feel that earthquake? So we're simply going to come in and use the distance formula with the center and the given point. So we'll have the square root of 13 minus 3 quantity squared plus 1 minus 7. Make sure you're in the correct order. Let's double check. So it's 13 minus the 3 and the 1 minus the 7. So 13 minus 3 is going to give me 10, which I'm going to have to square. 1 minus 7 is -6, which we're going to square. Gives me 100 plus 36, which is 136. Because we want to know whether or not this number is less than 12 squared. Well, we can already see it. It's 136 is less than 144. But in case you're not understanding that, we can go ahead and take the square root of that and find an approximation. It's 11.7. So that person is 11.7 miles from the center of the earthquake. So yes, because the earthquake can be felt up to 12 miles, they're going to feel the earthquake. To answer the question, yes, they will feel the quake. It's a nice quick example of why you would need it. You can also use the same idea to do a search pattern in a boat, right? Cell phone signals are circular cells like this. And finally, example 5. Says the original Ferris wheel was built in 1893, and it's actually named after somebody whose last name was Ferris, hence the reason it's called the Ferris wheel. It had a maximum height of 264 feet and a wheel diameter of 250 feet. Find an equation for the wheel if the center of the wheel is on the y-axis. Okay, they're giving me a pretty good picture of what's going on. So here's the y-axis sitting here. And we know that the center is sitting in here someplace. Now it doesn't sit on top of the x-axis. So in other words, the Ferris wheel is doing this kind of thing. And how do I know that? From the words alone, it tells me that the maximum height is 264. So I know up here, I'm at 264. They tell me the diameter is 250. So the distance from here to here is 250. So if I subtract those two numbers, then this is down here at 14. So in other words, you got to climb up to get in or whatever. There it is. Well, we need the center. Well, the center would be half, the radius would be half of this. So if the diameter is 250 feet, then the radius would be 125 feet. Well, I'm already at 15 feet up. So if I add on 125, we're going to end up at 139. So this is at 139. So we now know that the center is at 0, 139. That's all we need. Now we can write our equation for the the equation of the Ferris wheel circle. There we go. So we're going to have x minus 0 quantity squared plus y minus 139 quantity squared. And that's going to be equal to that radius squared. So cleaning that up, I get x squared plus y minus 139 squared equals, and 125 squared is big. It's 15,625. And there's the equation of that Ferris wheel. So if the homework were to come in and ask you for intercepts when you graph your circles, don't forget what you already know about finding intercepts. To find the y-intercept, you let x equal 0. To find the x-intercept, you let y equal 0. Sometimes they're really ugly. You may need to use the quadratic formula to find those to find those intercepts. So it adds another layer to graphing those. Thank you.